the new session of our Video Geeks channel. So today we have Hanil Mistry and Dev Gundalia. So Hanil is presenting today, and the topic is something MLAG. So how are you, Hanil and Dev?
Yeah, thank you, Arshil. I'm fine.
I'm fine too.
Okay. So I guess we can kickstart our session. So
Yes,
let me just yeah. So in the previous video, let me just give you what you can say overview for the let's say viewers who might have the first time on Video Geeks. So in the previous video, we have seen the first session of MLAG. We can quickly revise what we have seen in the last video. So this was the agenda for the last video, just the introduction of the MLAG. So we have seen that what was the LSTP, where it has been limited in terms of redundancy, and other than that, we have seen these were the requirements for the LSTP. This was the part that was getting compromised, and what was the way? This was the way that we have tricked the MLAG. And remember how we have seen the mapping that from the STP we can trick the STP using port channel, and from the MLAG we can trick the port channel using MLAG. So that was the comparison that we have seen. These were the requirements to have the MLAG, and at last we have seen some of the facts about MLAG, that it is not a vendor, what you can say, it is not the IEEE standard protocol, it is vendor specific, and it is for the Arista it is MLAG, and for the what you can say Cisco it is VPC or virtual port channel. And we have seen the namely what were the what were the components of the MLAG. So that was the end of session 1, and now in this session we will deep dive into MLAG and we'll see how to configure it. So let's just with that we'll go through the introduction. So in this video we will see what we have seen so far, what are the components, what are the MLAG operations, how to configure MLAG verification, and at last we'll see one problem exercise for the audience. So why MLAG? So first of all, we have seen that how we can configure a port channel, right? But there was the one thing, that port channel was giving the redundancy in terms of, let's say, ports. Let's say one of the ports gets down, then other port will still form this logical link that we have created using the port channel. But what if one device gets failed, right? There was no point of having port channel in that scenario. So for that purpose, we thought that we could include the two links that are going to different devices, and we can form a port channel over there. So that way we can introduce more redundancy. Let's say one of these device gets down, then other device will proceed in the same way, because this is the one link. But what was that? There was one catch. So what is that? So when port channel will be formed, they will exchange something called system ID while forming a port channel. So system ID is a mixture of priority that is selected by default by the switch or configured manually, and the MAC address of the switch. So let's say this switch and this switch, they will have, let's say, different MAC address for sure, but they can have same priority, but still they will have different system ID. So let's say if we want to configure port channel, so they will exchange system IDs with different, let's say this switch will exchange system ID B and this will exchange system ID A. So port channel will not be formed, because this that is a rule of the port channel, that what and all are the ports that are in same port channel, they should be receiving same system ID. So this is not possible. So it will not form a port channel in that case. So how MLAG can help here? So we can configure MLAG, and for that, first of all, we need to have a port channel between two of the switches in which we want to configure a port channel. So let's say we configure port channel between these two switches, and these two switches, they have system ID A and system ID B, and after that we have configured the MLAG. Now they will not exchange the system ID, but they will choose one of these switch as primary, and they will exchange something called LSCP ID. And now this switch will receive, rather than system ID, they will receive the LSCP ID that has been configured and communicated like after we have configured the MLAG. And that's how we pick LSCP. And now whenever they will exchange these LSCP ID, which is let's say X in this case, so LSCP would get configured, like it will get configured because it will receive same system ID from both of these ports. So that's how MLAG can MLAG can help us to allow us to introduce redundancy between devices. Previously, when we have created port channel, it was port physical port redundancy on physical ports, but this is redundancy on physical devices. So now with that, you might have been you might have get more idea like what is MLAG truly. And now with that, let's get into the components. So there are 4 components of MLAG: peer switches, MLAG domain ID, peer link, peer address, that we have seen in the last video. So now let's just get more idea on all of them. So this is the topology that we will be seeing in configuration also, and while we talk about the MLAG also. So let's say if we are configuring MLAG, so peer switches, so on the switches on which we will configure the MLAG, they both switches, they are called peer switches, as namely you can obviously guess that because of they are peers. Now second one is MLAG domain ID. So basically it's alphanumeric ID configured on peer switches. So let's say we configure MLAG 1, 2 or anything combination of alphabets and numeric that you want. The third one is peer link. So basically the layer 2 port channel configured on peer switches, that is called peer link. In this case, this port channel that you see over here, that is peer link. And the last one is peer address. So peer address is like the IP address for the communication. Let's say we have configured MLAG, so there will be one one interface, and generally it is SVI, switch virtual interface configured, and specifically SVI, and that is also recommended that we use 4094 while forming a MLAG and on both the switches basically. So that is the rule, or you can say the recommendations that we need to follow. So SVI 4094 in order to communicate for MLAG on both the peer switches. So they will communicate using this SVI, and all the information, all the packet exchange that will be happen by the help of this SVI 4094 and the IP address that we have configured. So these are all the components, and namely MLAG does just these 2 operations. So first is MAC table entries will be synchronized. So on both of the peer switches, so the MAC table entries will be synchronized. So that's because let's say there will be one packet coming from the, I will just need this topology. So let's say one packet coming from this switch, it will goes to this switch, and let's say the MAC that is in here, let's assume the first case that MAC address is here but not here, so one of the MAC address, and packet is coming on this device, so it will not get redirected, like it will not get forwarded, or the packet will be broadcasted. So that should not happen, because this should appear as a logical link, and if they are appearing as a logical link, so MAC MAC entries on both of these devices should be matching. So that is the first operation. And the last one is LSAP BPD will be of primary security only. So this, as we have discussed earlier, so mainly MLAG will do these two operations only. So now with that, let's just get into the configuration, how we can configure. And for that, actually, I have a different kind of
You
setup.
can say it.
Yeah. Okay. So here we have ACT labs that we can see usually on the Arista. So this is topology. You just not go with this PO10 and all this stuff. You just go with these devices. So this is the we will use these three devices: route reflector, tower core 1, and tower core 2, and this link Ethernet 24 4/30, 25 4/30, and these two. Okay, to create the topology that we had in the example, right? And if you are not sure that like about topology, we can just go over here and we can verify. So for the verification, we can enter show LLDP neighbor, and you can see Ethernet 24 that is going for tower core 1, 24 going for tower core 1, and on tower core 1 you can see 4/30 that is going for route reflector. Over here 4/30 that is going for route reflector. So that way I have created this topology, and now we can just follow along with the how we can configure the MLAG. So let me get rid of this and this also. Okay, hopefully route reflector is visible, tower core 1 and tower core 2 these are visible. So first let us just configure tower core 1. So in order to do the configuration of MLAG, it is what you can say bit of a easy, but you just need to be aware about some steps that how you are going to configure it. So just a second. So if you want to if we want to configure the MLAG, right? So just we can first see we are configuring now tower core 1, tower core 2. We'll configure all three devices. And how we want to configure? First we'll create port channel between these two ports, right? And then we will configure MLAG on these two devices. So now tower core 1 and tower core 2, they will communicate, and they will select one of these switches as primary switch, and they will exchange same system ID with the port channel that we will configure between route reflector and tower core 1 and tower core 2. So what we need to do, first we need to create three VLANs. So how they will fit here? The first VLAN, that is for this port channel that we will create between route reflectors and tower ports. Second VLAN that we will create for these two ports 4/20, so basically communicating between tower core 1 and tower core 2. And last VLAN that is for communication of this MLAG, that is 4094 that we will create. So let's just go on with the configuration. I will go a little bit fast. So we'll create 10, 100 and 4094. So 4094 is mandatory, but these two you can completely take upon your choice, right? We'll just quickly exit. Now on VLAN 4094, we'll create one trunk group, right? That is MLAG. You can name it anything that you want, right? So that is it for the VLAN configuration. Now second step is to create interface for the MLAG communication. So for the MLAG communication, we'll use VLAN 4094. So we can just go back like this, interface VLAN 4094. So this will create SPI for VLAN 4094. Now we can just give the IP address 192.168.12.1/24, right? So you can give any IP address, but let us just go with this. Now we can just give no shut. Okay. Now we need to create two port channels. What are they? First is to like for us to communicate tower core between tower core 1 and tower core 2, and the second port channel for the communication between route reflector and these two tower core switches. So we'll create interface port channel 10. Let's say port channel 100, right? We'll use port channel 100 for the communication between tower core switches, right? And now we can just go like this, tower switch port mode trunk. So we can any VLAN tag traffic can go through this port channel, and switch port trunk group MLAG. So remember, this group name and this group name should be same, right? And now another port channel 10 that we will create for us for communication between route reflector and both of these tower switches. Okay. Now this port channel, we will put this port channel into VLAN 10, and we need to configure MLAG interface ID. So we can give any MLAG interface ID. So the way we create port channel, so port channel 10, 100, we can just create MLAG 1, 2, 3, any port channel, any MLAG interface ID. So let's say MLAG, we will create MLAG interface ID 1, right? And now we need to configure MLAG, but first this same configuration we need to configure on tower core 2. So first VLAN 10, 100, 4094. Now VLAN 4094 trunk group MLAG, and now we can create interface VLAN 4094 IP address 192.168.12.2/24, and we give no shut. Now we need to create these port channels. So interface port channel 100 and switch port mode trunk switch port. Now we need to create trunk group MLAG, right? And port channel number 10, interface port channel 10. Now for this port channel we need to give it switch port access VLAN 10. Okay, and same way MLAG interface 1. Remember, this MLAG interface should be same, right? Now we are good to go with the configuration of MLAG. But before we do that, we need to put the ports to be part of port channel, because right now we have just created the port channels. We didn't specify that what are the ports that are in port channel 100 or port channel 10. So for the port channel 100, this 4/26 and 4/27 are there. So we can just configure port interface Ethernet 4/26 and 4/27. Okay, and now we can just put these ports, switch port access VLAN 100. So this uh, we will put this in VLAN 100. Why? Because remember that we have created this port channel 100. So this is trunk, but we'll put these both VLAN, these both ports into VLAN 100 for communication of let's say individual the packet exchange. And now we can just put them in channel group 100 mode active. So that way we have configured this both of these ports to be in port channel 100. Now there is one port, this 4/30. For that port we'll put into port channel 10, right? And now before we configure the MLAG, let me just show you this and show spanning over here also. So spanning tree. So see, right now we have these two ports into spanning tree, and we just verify the output over here also and over here also, right? So we have configured ports to be in port channel. We'll do same for the tower port switch 2 also. So over here we can just get rid of this extra output, and now interface ETH 4/26 4/27. Okay, now we'll put both of these ports into VLAN 100 and we'll configure channel group 100 mode active. So now we have configured both of these ports to be in port channel 100. Now there is just one port remaining. Okay, now we will put this port into port channel 10. Okay, so now we are all good to go for the configuration of MLAG, but before that we need to configure port channel on this route reflector also. So over here what we'll do, we'll create VLAN, we'll go the step by step, right? So first we have created VLAN. So let's just create the required VLAN. Here we will not configure MLAN. So we do not need VLAN 4094. And about 10 and 100, remember 10 we have used to configure the port channel over here. So we just need the VLAN 10. We create exit, and now we'll create port channel. So interface port channel 10, and now switch port access VLAN 10. And remember the MLAG interface ID that we have configured on both of these switches? That was 1, right? So we'll configure the same over here also. And now for both of these interfaces, 24 and 25, we'll put them into this port channel 10. So we just need to write channel group 10 mode active. And now that is it. Now we can go ahead with the MLAG configuration. So MLAG configuration is very easy. You just need to write MLAG configuration, and now remember all those uh, components of the MLAG that we have seen. So we need to configure all them. So first is domain ID. So remember domain ID that we have seen, that is the alphanumeric combination ID something. So we can just take MLAG12. Now local interface. So that is the VLAN 40 94 that we have created. Now peer address. So for the tower core 1, the peer will be tower core 2. And remember, we have configured this VLAN 4094, this IP address. So this IP address, that is peer address for tower core 1. So we can just configure 192.168.12.2, right? And peer link, that is the last component. And what is the peer link? So the link, that is port channel that is being configured between these two. So that is port channel 100. So we write PO 100 and we can just do exit, and we'll do same for this tower core 1, tower core 2. Get rid of this extra output, and we can just write MLAG configuration domain ID, that is MLAG12. Remember, this domain ID should be same. Now local interface, that is same, VLAN 4094. Now peer address. So for this switch, peer will be tower core 1, and tower core 1, if we see the running config, so this is the IP address 12.1. okay, so 192.168.12.1. so this is the peer address, and peer link, that is same, port channel 100. So now that is the end of MLAG configuration. And how we can verify that we have all the things good to go? So for that, we can just exit, show MLAG, and you can see negotiation status. MLAG status is active, negotiation is connected, all these things are up, right? And all the information, all the components that you have configured, you can see here. And remember, if this is active, you can, for the double verification, you just need to verify peer configuration is consistent, right? And over here also show MLAG to see this is active. And now for the double verification, what we can see is we can just type show interface status and show spanning. So you see, previously it was two ports, this 24 and 25. Now you can just see this port channel, because we have bundled these two ports to be appear as a one single logical port. And now we can similarly observe the effect over here also. Show spanning tree. See this port channel 10, that is being selected as root, and over here also so spanning tree. See, so that is how you configure MLAG. And now these two switches will appear one as this route route reflector, and that's why you can see this one link only to this spanning tree. Also here also you can see. So that is how you configure MLAG. And how I will just stop my screen share from here. And yeah, now so see, this is the exercise for the audience. This is the topology. This is the final output that I want you to configure, and this is how it will look like. So tower core, when you configure MLAG on these three groups, so this will look like this. So yeah, That is it from my side.
Yeah, Anil. Uh, just a note that that's a great concept, but I'm more impressed on the domain in which you performed this practical. It was arc.arista.com, something like that, right?
ACT, yeah,
Okay.
act.c.act.arista.com.
Yeah. So if our audience wants to perform those practicals, where could they write
Yeah,
those commands? And
that is the question. See, I was hoping that I can configure and show it to you on Cisco Packet Tracer, but Cisco Packet Tracer don't support that kind of what you can say feature. So they have VPC, but they do not allow us to simulate VPC on Cisco Packet Tracer because they all are different Nexus kind devices category. So you cannot perform this on Cisco Packet Tracer. But let's say you have the iOS of Cisco devices who have feature VPC, so you can grab that from the online and you can use GNS3 to simulate VPC.
okay, that's fine.
Yeah, so that is
Yeah.
it.
Yeah, that's it. Thanks for watching, guys. See you in the next one.
Yeah, bye bye.